Following on from the previous video, we were trying to find out the volume of 3D solid, and we got to this stage here where the volume is given by this. So now it's just a matter of evaluating this. So this is a constant, this is a constant, so factor it out, that will then give you this. So now it boils down to us integrating this. So to integrate this, so to integrate this, your eyes should zoom into this bit here, and then create your triangle in such a way that this will be true. So if you make the hypotenuse to be r, the opposite to be y minus r, then the adjacent will have no choice but to be this. So once you've created your triangle, you can then immediately obtain this, because once you've got your triangle, sine theta will be opposite over hypotenuse, will be opposite over hypotenuse. So times and then once you're here, you're really trying to obtain dy. So y is stuck in here. So make y the subject. So that will then give you this. And once you're here, then differentiate both sides. So this will then become this, and the y will then become dy. So now you've got a term for dy. So dy equals this thing here. So we can then put this into the dy. And then once you've done your diagram, you can also obtain this, because once you've got your diagram, cos theta will be adjacent over hypotenuse, times both sides by r here, then it will then give you this. So this complicated thing here is this thing here. So we can now put this into the complicated bit here. And then don't forget dy earlier was this. Dy we can put it into here. And then now you've still got the y on its own. Well, y on its own, look at this bit here. You've got y equals this thing here. So you can put this into the y here. Then this whole thing here will then become this. Okay, and going back here, this is a definite integral, because we are integrating from here to here in with respect to y. So now that we've made this substitution, we are now in the d theta world. So by right we should make the adjustment to the bound. So we should by right make the adjustments here and here, but leave it for the time being, because later on we're gonna convert all the thetas back into the original r and small r. So we can but by right we should convert this. We should make the adjustment to this and to this, but leave it for the time being, because later on we're going to convert all the thetas back into the original r and small r. Okay, so leave it for the time. Leave the limits here for the time being. Okay, so let's carry on. So we were trying to integrate this. Use substitution. Then this whole thing here will then become this. So now tidy this up. So you can merge these two together, and then blah blah blah. Tidy up. It will then give you this. So now, now that we are here, we are currently here. So now evaluate this as one integral, and then evaluate this as another integral. So remember, you've got to do this and you've got to do this. So that will then give you this. So basically, we're trying to evaluate this one at a time. Okay. So if you look at this here, this will then give you this thing here. Don't forget, this times this will then give you this. This is easy to integrate now, because we've done this many times. To integrate cos squared, we would immediately use this. So later on we will sort this out. And then this thing here is actually easy to integrate, because when you're trying to integrate something, try to keep an eye out on something being the exact derivative of another thing. You see, this thing here is the exact derivative of this thing here. Let me just give you an example here. If you look at this is in fact a derivative of this, because if you look at this, hang on, start out with your initial guess, cos theta to the power of 3. Now if you differentiate this, it will give you 3 cos theta squared, and then times the derivative of this thing here, which is minus sine theta. You see, this sine theta is this sine theta here. So to integrate this, it's actually quite easy. It will, well, make the adjustment. It would be minus a third here as your adjustment to this. So if you make the adjustment here, minus a third, then it will give you this thing here. Well, if you integrate this, it will give you this. So this thing here, we are going to turn it into this, and we will sort this out later. Well, integrating this will give you this plus a constant. So this is your constant here. So we are currently here, and then factor out the half here, and then that will cancel out with this thing here, giving you a 2. So we are currently here. Okay, so basically just move this c to the end here. It's not, this c is not that important. It's just a constant. And then now we need to integrate this. Well, integrating this with respect to theta will give you theta. Integrate this will then give you this plus a constant, but we can merge the constant with the previous constant here. Basically, integrate it. This whole thing here will then become this. Okay. So hang on. So now we need to think. Oh yes. Now we can multiply this out. So this times this will then give you this, and then this times this will then give you this. And as always, we've done this many times as well. Well, when you have when you have sine 2 theta, we can replace this with this thing here. So that will then give us this thing here. Okay. So now this is our answer, but we don't want the answer in terms of theta. We want it in terms of capital R and small r and so on. We don't want it in terms of theta. So to turn back to revert to translate all the thetas, we would revert back to our original diagram. Which was this, and then from the diagram we can easily obtain sine theta equals this thing here, because sine theta is opposite over hypotenuse. So sine theta is this thing here. So if you look at this sine theta, we can put this back into here, and then we've got cos theta. Well, cos theta is this thing here. So once you put your diagram, you can also obtain cos theta. Cos theta is adjacent over hypotenuse. So we can put this into the cos theta here. Into the cos theta. We can put sine theta into this sine theta here. And the theta on its own, we can inverse this thing here. So well, and then cos cubed would be us cubing this thing here. So it would be this whole thing here cubed, which is this bit here, and then this thing cubed here. So this bit here will then become this. This thing here will then become this. This thing here will then become this. And the sine theta is this thing here. So when you're here, convert it to this. And then now this was our original bound here. We were trying to integrate from here to here. So we are currently at this stage here. If you try and evaluate this, so currently you've got this block here, you've got this block here, and then you've got this big block here. So if you evaluate this, if you put this into here, if you put this into here, basically this thing here will become 0. This whole thing here will then become 0, leaving you with just this. Because if you try and put this into into the y here, because remember we are integrating with respect to y. Put it into here. You've got r, capital R plus r, and then here you've got to take away capital R, leaving you this thing here being r, small r. And then when you square it, when you square it, and then this whole thing here will then become 0. So square root of 0 will be 0, and then you cube the 0, that would be 0, and then blah blah. This whole thing here will be 0. This whole thing here will be 0. So it's just really, it boils down to you evaluating this middle term here. So this whole thing here will then become this. Will then become this. So now we can factor this out. So that would then give us so this whole thing here, factor it out, it will then give us this. So now if you evaluate this, if you put this into the y here, so you've got capital R plus R, and then you've got take away capital R, and then take away. So this, if you put this into here, it will give you this, but then you've got to take away the capital R. So that would just leave you with small r. Small r over r is 1. So you've got inverse sine of 1 in effect. Do the same here. You're going to have negative 1. Well, this thing here will then become this, and then overall your answer will be this. So you've got half pi plus half pi. That will give you 1 pi, and then you can merge the 1 pi here with this pi here. That will give you pi squared. So overall your answer will be this. In the next video I will show you a more efficient way of doing it. Okay. The reason why I'm doing it the long way is just hopefully to give you an insight into what's going on.